So a little bit more done to the valve amp. I've just been tinkering around in here again for a couple of hours each day before work or just popping in after work. So I've got the input sockets put on here now, volume control, function LED, power switch, that's on the front panel. Back panel is power connector, is a Nutric power con. It's got the holes, the fuse holders will be going in here, so that's going to be one for mains input, one for heater supply and one for HT supply. The speaker connectors are just these, you know, they're not the best in the world. They're just push plug, little tab down, push wire in type ones. If you can sort of see there's a hole, you can't really see it, there's sort of in there. This was a power supply, like I've mentioned before. That was where the output connectors used to go. So a piece of an old project I'd worked on. They just cut a bit of circuit board off, drilled it out and used it to cover up the holes, and as a mounting plate for the speaker connectors. So that is the chassis work all finished apart from this little board down here. The heaters are going to be running AC, but they're also going to be running a standby mode. I'll go into that in a bit. So basically it's going to be some DC on this board, rectified DC just to run the relay. That's what the power switch is actually going to switch rather than the mains. The relay will turn the AC on to the second transformer, because this transformer is a mains transformer but running in reverse. So 9 volt AC in gives me 240 volts AC out, which goes to the HT. So when it's off, the relay will open, it'll kill the supply to that, so the HT will go dead. But it will also then switch over the heater supply to a longer resistor chain, which will drop it down to 4 volts. Now, 4 volts, according to Morgan Jones's valve amplifiers, is a good standby voltage. It stops the valves going through full thermal cycling, it on, off, you know. It's a piece of tungsten wire, it's thin, it's going from room temperature to glowing orange hot, it's having to expand and it contracts again as it cools down. I'm no metallurgist, but I know it affects the crystalline structure of metals and stuff as you heat them up and cool them down. And over time it will fatigue the heaters and cause them to fail. You know, you don't want to be running them on all the time because that will cause cathode poisoning and it also wastes energy. So running them at full 4 volts allows them to sit pleasantly warm, stops them undergoing full cyclic thermal change and thermal shock. It also keeps them at a low enough temperature to stave off cathode poisoning. And it also allows the amplifier to come out of standby and sort of go into power on almost instantly. At 4 volts there's going to be some emission, it's not going to be full emission, but it's some, so it power on as soon as the HT builds up, which takes a fraction of a second. The amp will start working, and it will also stop cathode stripping from there being HT applied to the valves when there's no heater current. When that happens, you can never generate a pure vacuum. There's going to be some gas molecules in the valve, and they can receive a positive charge from the anode, and they become a high velocity ion, and they bombard the cathode, and it damages the emissive surface. I think it's something like that. Is it an ion? My terminology's off. It's a positively charged particle. I think that's an ion. I guess it's an ion. It's a gas flowing. It's a charged particle of gas. So I think that makes it an ion. Anyway, please feel free to correct me if I'm wrong. The top of the board is also done. So that's the valve sockets there. The 4 output valves will be here. That's one channel. That's the ever. That's the input valve. A little close together on, barely a finger's width, but this is running relatively low output. It's more designed for long life rather than squeezing every watt out of them. So they're running class AB. They're going to be running pretty cool. So there's more than enough room between them to keep them cool. I mounted them here because it was either here. You can see there's obviously they've mounted into this part. It was either mount them here, mount them offset like this, which would have looked weird, I think, or mounted them really far apart. Didn't like the look of that, and it then would have meant they've taken up more room at the top end, moving valves near the transformers and stuff. So I went with this. Obviously, I had to. This bit of metal was going to get lost out the middle, but it's here nor there. Now, this is going to be a dual mold, a moldy amp. It's going to be a very moldy, smelly amp. No, it's going to be a dual mode amp. So it will run in triode or Pentode mode. Each one of these valves has a resistor on the grid 2. Data sheet specifies dearie me, what's going on? Data sheet specifies 2000 ohms or so on each grid 2. So in Pentode mode, the valves connect to the power supply via grid 2 on that resistor. In triode mode, that resistor connects straight to the anode of each valve respectively, and then they're running as triodes. That will be accomplished with switch here. This isn't the actual switch, this is one I've just put in just to show it will be there, because I appear to have lost the 4-pole dual throw switch I need, so I've had to buy a new one. What was I just on about? So the next things to do is screw everything in after I've knocked up this little circuit board here. All the holes are drilled for everything else. Mount everything down and start with the wiring. So heater wiring first. It's going to run around the chassis, come up the back. Where it comes up on the underside here, it's going to tee off. The heater supply pins are like these innermost ones. Going to tee off and finally go to the input valve. On this tag strip is the output valves, per channel, bypass capacitors, cathode resistors, grid resistors, Miller compensation capacitor. That's the underside of the switch. So there's going to be main anode voltage coming up to these valves via the output transformers. As the anode connects to the transformers, the output transformers primary comes up to each valve. It's going to be the cathode feed coming up, which is the 0V rail from the HT, and a heater. So that's going to be 4 wires for transformers, 1 cathode, that's 5 wires, 2 heaters, so that's 6 wires going to be coming up here, support. The triode Pentode selection is all going to be done on the top here, so I don't have to run that down to the underside. Then this valve itself is going to have 2 cathode, 2 anode, and 2 grid resist, 2 grid feeds coming up. They're all plug-in. They go to that board just underneath, so they can come down the side. These ones are coming at the back, so I can sort of fold it over. So you know, you want to service it, I can take the lid off, fold it over like that. Whereas the input valve, you know, I can have this wire coming up. You know, it's unpluggable, it can loop around. But yeah, that is it so far. So heater wiring first. I've got some little sticky pads you put in here to sort of hold everything where I want it. Not a massive amount of work to do now, it's just tedious and slow. You know, you've got to twist all the heater wiring meticulously. It's put it in the drill, draw it out, nice tight twist. Now the little thing I just thought I'd mention is the power LED here is a dual colour LED, so in standby it'll be red. When the valve's in operation, the amplifier's in operation, it'll be green. But when it switches between standby and on, I'm just going to have a capacitor which is parallel to the red LED. So when the feed to the red LED is broken, that capacitor is going to take a small amount of time to discharge. And because of that, for a short while, both LEDs will be alight. And that means rather than just coming from red to green, it'll actually transition through an orange colour. Red and green together make a sort of orangey. If you get them right brightness, they make a pleasant orange. And it will transition, it'll just slowly dim down from orange into green. It's a sort of, I think it works kind of well with the way the valves work. The valves don't instantly go to full on. They take a few seconds to sort of transition from standby mode into full operation. And the LED, you know, it's just a little aesthetic finishing touch. But anyway, next time, hopefully, I'm planning on having the next video will be at least the heat wiring, testing the heater voltages, seeing if that little LED works as I hope it's going to work. Obviously, this will all be bolted in. Fuse holders will be in. Got some more fuse holders coming because the ones I'd brought from eBay were shite. They were like manufacturing defect, and the bodies of them being put together the wrong way round. They probably made like 1 million of them before they noticed that. So I won't be using any of them. They've gone straight in the bin. And so, yeah, if you've watched the other parts of this video and you've watched this one and are planning on watching the next, I'd just say very grateful for that. Thanks for watching, and hopefully have something good for you soon.